All right, here we go. So we're going to be applying the law of sines formula when you have one angle and two sides. All right, we're solving for an angle here. All right, so we have one angle and we have two sides. They actually gave us three. I'm going to pretend like that didn't happen. I don't need that one anyway. All right, so this is what they would call the side-side angle kind of version of this. These are actually the ones that will give you much more difficult problems than you could even imagine. Like, it really takes a while to wrap your mind around the harder versions of these. I'm just going to stick to the simpler ones, okay? The ones where these play nicely. Okay. So here I go. The setup here, I've got sine of, actually, you remember how we had A over sine of A is equal to B over sine of B? This version was really helpful when we were solving for a leg. But what we're going to do is we're going to solve for an angle. I recommend you would flip these. All right. It's definitely, it's possible to solve it like this, but you're involving an extra step. It's not that big of a deal. I mean, I honestly don't even think about it. I choose one, whichever one the formula gives me, I just use it. So I'm going to use that to solve for x here. So I'm going to do sine of x. That's going to be my top part. And that's directly opposite. That's the angle that's opposite 21. And that's going to be equal to 26 is my length down below, and that's opposite 88. So I'm going to do sine of 88 there. All right, so to solve this, what I need to do is get rid of this 21. So I'm going to multiply by 21. Multiply by 21 on both sides. They cancel, and I get sine of x is equal to sine of 88 times 21 over 26. And you could punch this into your calculator as it is right now. But the next step is going to be the one where you have to think about it a little. You want to get the x by itself. So what we're going to do on our next step is we're going to be taking the inverse sine of both sides. All right. So if I wanted to get x by itself, I would do sine inverse of both sides. So I would do it to this side. That way, these are just going to eat each other, and you're going to be left with x. And then whatever comes out on this other side, sine inverse of this whole mess, this is going to be where your answer is, times 21. All right. I know it looks ugly. This is probably a little funkier than it should be. The way that you would do this with your calculator is you would take this part right here, and you're going to be multiplying by 21. So we're going to do 21 times sine of 88, right? And then we're going to divide that by 26. Okay, so that's what this part equals right here, is 0.807. But since you're wanting to find out what angle you have to take the sine of to get that, that's where this sine inverse comes in. We're going to take the sine inverse. We're going to take the sine inverse of this 0.807. Okay. So I'll do sine inverse, that was second, and then sine of the 0.807, but I'm just going to go I'm going to do my last answer is what I'm going to do. So second, and then that button down there, last answer. Or you can just arrow up and do it like that. This is going to give you a better approximation of your angle. So I get 53.823. That would be it. X would equal 53.823. All right. 53.823. Now, if I wanted this third angle, I could just do 180 minus both of those, and that would give it to me. But for the sake of practice here, let's go ahead and set up another law of sines equation and solve for it. But I actually do need, I actually do need this side over here, don't I? What was that, 16.1? I guess I needed that. I didn't even know I needed it. But I'm going to solve for that angle next here. We'll call that y. All right, so my equation is actually going to be identical to this one up here. I'm going to have sine of y. That's my top part because I'm solving for y, so I put that up top. And that is across, that's across from this 16.1. 16.1. And then for my other one, I just got to pick, an angle and an opposite and a side that's opposite where I know both of them. So I could use these or I could use these now. Okay, I'm just going to use the same ones from before. Sine of 88 divided by 26. And then we'll just use our calculator to solve this here. All right, so I'm going to multiply through by 16.1. So it's like cross multiplying here. So I get sine of 88. I'm going to times that by 16.1. And then I'm going to divide that by 26. So when I multiplied by the 16, I got the 16 out of the denominator. And so that's how I'm getting sine of y by itself. So I'm going to take that answer and divide it by 26. And now I need to do the sine inverse of this answer. All right, so sine inverse of my last answer. And that gives me 38.23. And that makes sense, 38.23. Because now all of the angles would add up to 180 degrees. Ding, 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 ding. That's it. All right, do one more here. They're giving us this one in words, and I am not going to try to draw a picture. I'm actually just going to set up my my little sine equation. All right, the measure of angle A is this. Side A, which is the one that's across from that angle, is 5 units long, and side B is 12 units long. Find the measure of angle B. So sine of B, that's the one I'm solving for. I'm going to put that as the top part of my fraction. The side that's across from that is 12 units, it said. Side B is 12 units. And on this side, I'm going to have sine of angle A, which is this 24.63. 3, repeating, over 5 units. All right, so these are the ones that would typically kind of throw people for a loop. These are the ones where I'm going to make some separate videos down below, and if you want to go watch them, boy, you should. They are kind of confusing. Law of sines, it's a lot easier than law of cosines, which we'll talk about later, but there's these ambiguous cases and impossible cases that sometimes happen, all right? So you got to watch out for those. And usually the ones that you'll see like on the ACT and stuff, they avoid that. They just go with the simpler cases like this, okay? All right, so if I'm solving this for angle B, I'm going to times by 12. So it's going to be sine of 24.6, and I'm going to put in some extra 3's here. All right, times 12. All right, so I get this, and then I'm going to divide this by 5. Divide this by 5. Cool. And so I get 1.00343. Now, if I take the sine inverse of this, I'll show you real quick. Sine inverse of my last answer, I'm going to get an error. Remember how sine doesn't actually get up to? Sine never reaches anything past 1. That's the reason I'm getting an error here. And like I shouldn't be getting 1.00343. This is actually a rounding thing that my calculator's doing. this is supposed to be a solid 1 right here. So what I really need to do is sine inverse of a solid 1, right? And that's going to give me 90 degrees. My angle B is going to be 90 degrees. And hopefully you saw kind of a hint towards this from the very beginning. When you've got a side length that's 5 and a side length that's 12, the other side length is probably 13. All right, 5, 12, 13. It's one of your popular right triangle Pythagorean triples, right? That's why I kind of felt like, I was like, all right, I know there's going to be a 90-degree angle in here, probably. And then whenever I saw that that was giving me an error on the one side, that was how I knew to do that. You probably won't run into this, right? Yours will probably play much nicer. All right, that's it.